The 7th. And we were looking at 52, you said, page.
Actually, we did 58 last time, but I think number 61 on 670 is the same.
So 61 on 670, very good. 670. And 61. The base of a triangle is 4 more than twice its height. So we have a triangle, the base, and this is the height. And it says the base is 4 more than twice the height. If the area of the triangle is 42 square centimeters, find its base and height. Where do we start?
I get so overwhelmed with those.
So the area is 1/2 times the base times the height. That's the formula for the area of the triangle. And that equals 42. So we are told that the area is 42. So I will have to replace b by 4 plus 2h in this formula. I will multiply both sides by 2 first. bh equals 84. And then I'll replace b by 4 plus 2h, h equals 84. Now this becomes a quadratic equation, which is 2h squared minus 4h minus 84 equals 0. So I distribute h to 2h, I get 2h squared. I distribute h to 4, I get positive 4h. And then I subtract 84. This is a quadratic equation. I will divide both sides by 2. I cannot divide by anything else. So then I have h squared plus 2h minus 42 equals 0. And I am going to try and see if I can factor this. If I can factor it, then I will have to use the quadratic form. Any questions? Since it appears that this is not factorable, because I can find two numbers whose product is negative 42 and whose sum is 2, then I will use the quadratic formula. Negative b plus or minus b squared minus 4 times a times c. So I change that into positive over 2a. So I should have had here negative 4 times 1 times negative 42, but I had two numbers that were negative. That's why I changed that into positive. You think okay?
Yes.
Good. We just started with a problem, problem 61 on page 670.
Okay.
Nicole had a question on this. So what I recommend here is simply factor out the 4, because it's easier if I factor out the 4 and I get 1 plus 42 divided by 2. You'll see in a moment. So when I factor out 4 from these two terms, 4 times 1 is 4, and 4 times 42 is here. But then I can break it up because this is a product now. So h will become negative 2 plus or minus. The square root of 4 is 2, and the square root of 43 cannot be simplified in any way, shape, or form. I will not cross out anything here. I cannot. But what I can do is separate it. Negative 2 over 2 plus or minus 2, the square root of 43 over 2. So then h becomes 1, negative 1 plus or minus the square root of 43. However, one of these two cannot be accepted. It's the one with minus minus. So h equals negative 1 plus the square root of 43 centimeters. Once I have the height, I have a formula for the base. in which I have 4 plus twice the height. So all I have to do now is 4 plus twice -1 plus the square root of 43. I distribute 4 minus 2 plus 2 the square root of 43. This becomes 2. So this is 2 plus 2 the square root of 43 centimeters. So the problem was asking us to find the dimensions. So the base is 2 plus 2 the square root of 43, and the height is -1 plus the square root of 43. So Heather, this was a problem in which we were told that the base of a triangle is 4 more than twice the height. So the area was given as being 42. So the area, the formula for the area is 1/2 times the base times the height. I set that equal to 42. I multiply both sides by 2 so I don't have a fraction to deal with. So b times h equals 84. And then I replaced b by 4 plus twice h. So b becomes 4 plus twice h multiplied by h equals 84. I distributed, combined like terms, moved 84 to the other side, divided both sides by 2 to simplify the numbers, and we could not factor, so we went ahead with the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times 1 times -42, but since I had two negatives, I already changed it into positive. So then here, instead of multiplying and adding and not knowing what to do with a big number, I realized that I could factor out 4. 4 times 1 is 4, and 4 times 42 is 4 times 42. Now this is a product. I'm allowed to split the product from chapter 10. The square root of 4 is 2, and the square root of 43 is the square root of 43. I'm not allowed to simplify like this, but I can separate into two fractions, -2 over 2 and this over 2. I simplify now, I can, so I have -1 plus or minus the square root of 43. But I cannot use both, because -1 minus the square root of 43 would be a negative number. Height cannot be a negative number. So I only used the positive, and then I went back to the formula for the base and replaced the height by -1 plus the square root of 43. I distributed, combined like terms, and we got the base. Good. Anything else that you worked on? Anything else that you would like to go back to? Problem, topic, anything? Anything else that you worked on? Okay, so let's go back for a second to our last lecture, which was this. Now let's see, maybe we have something here. So in this lecture, we looked at a lot of other problems with substitution. You may say, and I said that last time, I don't need your substitution. I know how to factor this into this. Then I'm fine. If you can factor this directly into this, it's fine. You don't have to use a substitution. I think it's more difficult than using a substitution. But the problem is not going to say you must use a substitution. It's recommended to use a substitution because it will be easier. Okay? So then we factored completely. This was a problem from before that we didn't finish because we did not know the quadratic formula. Then we looked at the three possibilities for the discriminant. So when the discriminant is positive, then the equation, quadratic equation, has two distinct real solutions. If the discriminant is 0, then the quadratic equation has one real solution. We know it's a double solution because it has to have two solutions. It's quadratic. But we say one real solution, but we really mean a double solution there. And when the discriminant is negative, then we know the equation, the quadratic equation, has two imaginary solutions. This was again the quadratic formula. This was a problem in which we were asked to find the discriminant. So we found the discriminant was equal to 0. That's why it had only one real solution. Then we looked at this problem. with the perimeter. Then we had some problem with the cost, in which we're asked to find how much it was such and such and such and such time. And then we were asked to find the time for cost 150. So we solved it using quadratic formula. Then we looked at more equations that are quadratic in form, from this time from chapter 11. So we had another one here, and another one here. This is basically related to chapter 10, because x to 1/3 is the cube root of x, right? So x to 1/3 equals -1 means the cube root of x equals -1. So then we looked at section 11.4 for nonlinear inequalities. We talked about linear, we talked about absolute value, we talked about compound. So these were the two new ones that we added to this list of inequalities. We have to factor. If it's factorable, if it's not factorable, I have to find the solutions using the quadratic formula. Once I factor, I will study the sign. It's up to you how you want to study the sign. I recommend this chart. So between -infinity and infinity, I come up with the zeros or the x-intercepts for each factor alone, as if it's by itself. So x plus 5 has -5 and x plus 3 has -3. These numbers have to be in an ascending order. This quantity is 0 at -5. This quantity is 0 at -3. I see that I have 3 subintervals. On the first subinterval, when I multiply a negative number by a negative number, I get a positive. In the middle subinterval, if I multiply the first one when it's positive and the second one when it's negative, then the product will be negative. And in the last subinterval, there are no negatives, so the product must be positive. Since I'm asked to choose a sign that is greater than or equal to 0, I look at the product and I see positive here and positive here. And that's the sign that is greater than or equal to 0. So I have to choose between -infinity and -5, union -3 to infinity. And that was the interval. So then we looked at another example, this time with 3 factors. And then we moved on to graphing quadratic functions. And we only, if I remember correctly, we only graphed this type. We did not get to graph this one. So we said, okay, the graph of a quadratic function. We listed the graphs that we know so far. We know 4. We're adding one more now. Linear, absolute value, square root, and cube root. So this graph, it's a parabola, which is a symmetric graph with respect to its axis of symmetry. There is an axis of symmetry, a vertical line passing through the vertex of any parabola. The shape can be this, or opening downward. It's opening upward when the leading coefficient is positive. It's opening downward when the leading coefficient is negative. But this was our case. Then finding the vertex. I said, how do I remember this piece? From the quadratic formula. So this is the discriminant, and this piece is the x-coordinate of the vertex. So -b/2a. If this is 5, then the y-coordinate will be f of 5. If this is 10, then the y-coordinate will be f of 10. So we determined -b/2a, we plugged it in, we got the vertex. And the x-intercepts, if they exist, and this is a very important discussion here. If it has a minimum, there are 3 possibilities. Either it does not touch the x-axis, obviously when the discriminant is negative. It touches in one point, we know it's a double solution, but the discriminant is 0. Or it crosses the x-axis twice. We know the discriminant is positive. So for here, the y-coordinate of the vertex will be positive. Here, the y-coordinate of the vertex will be 0. And here, the y-coordinate of the vertex will be a negative number. This is our situation. The y-coordinate of the vertex is a negative number. Therefore, the quadratic function or the parabola crosses the x-axis twice. Discriminant is positive. So here there were the solutions. When I find the x-intercepts, I said y equal to 0. And then when I found the y-intercept, I set x equal to 0. The axis of symmetry is the vertical line passing through this point, so it must be -3, x equals -3, and this is the minimum value of the function. So the minimum value of the function is -1. And we can easily identify the range, -1 to infinity. And then we looked at the word problem, and then another quadratic function to graph. We went through the exact same 6 steps, and we graphed it, and then we stopped. So what I would like to do now, I would like to look at the other shape, that's all it's left, and review for the test. Okay? So we looked at f of x equals ax squared plus bx plus c, and we had 6 steps. 1, 2, 3, 4, 5, 6. On the test, oh, sorry. So these are the questions, and they will be listed on the test. This sequence will be given to you, so you don't forget any step. You can do them in any order you want, but they will all be mentioned. So given or mentioned on the test as a requirement, so you will not forget. Okay, so this was discussed last time. Now the same 6 steps, but the function, the quadratic function, is given to us in a different form. It's the same thing. You'll see what the difference is, but it's the same thing. Because we know that we can complete the square on this. If you remember completing the square, I can change this into something squared plus a number. And this is the other form. So they are the same. They don't look the same. A is still the leading coefficient. In parentheses, I have x minus h. I'll explain in a minute what h represents. Of course, I have to have squared. And then plus k. Before we discuss what h and k represent, let's take it very slowly. Okay. So if I'm asked, and we did this, but remind me, maybe we didn't emphasize it enough. When I'm asked to graph this function, I know it's the absolute value function. I know it's a v. And I know it's the simplest possible absolute value function. If I add something here, or if I say this, these are combinations of the same thing. But these are not the simplest possible absolute value functions. This one is the simplest one. Nothing attached to it, so the graph is this. This is the absolute value of x. The same thing with the square root of x. Square root of x is a simple square root. The same thing with the cube root of x alone. It's the simplest cube root, and so on and so forth. What do you think will be the simplest quadratic function ever? What would be the simplest linear function ever that you think of? So we know the simplest possible absolute value function is the absolute value of x. What would be the simplest linear function? F of x equals, that's it. What would be, one more time, what would be the simplest possible square root function? Good. Let's come back now to the quadratic function. What do you think, in view of what we just discussed here, what would be the simplest possible quadratic function that no one can find a simpler one? But just simply looking at these 3, what would you think? It's okay if you're wrong. But you have to say x squared. Exactly. That must be the simplest possible quadratic function, right? It makes sense? Good. So let's start with that. I don't want to just give you, hey, here, memorize that. I don't want that. Okay, I want to discuss this that I'm going to show you in a moment, and then I'm going to ask you what this means, and you will figure it out on your own. Perfect. So now, will this function open upwards or downwards? Upward or downward? Right, because the leading coefficient is perfect. Very good. Now let's also think, what will be the vertex? So I know I have to graph this. What will the vertex be? What will be the x and y intercepts be? Right, is that clear? Does it make sense? Good, perfect. So then the graph must be something like this. There is no other way. What will be the axis of symmetry? X. Right. And it's symmetric, and it's clearly that this is the simplest possible quadratic function. Okay. Now, I want a new function. I'm going to look at and ask you, where do you think we will graph? Since I don't want all of them to be f, I'm going to call it this one f1. Well, let's say I want to graph x minus 1, everything squared. Obviously, I'm changing x, right? Instead of having plain x or x minus 0, right? I can write this as x minus 0, right? No change, right? That's x. So now, instead of 0, I have 1. So I'm changing x into x minus 1. So when I change x in a function, this happens. But now the question is where? Does it shift to your left or does it shift to your right? So let's think. If this function, when x equals 0, y equals 0, obviously, right, it crosses at the origin. Let's see where this is going. Let's say when x is 0. When x is 0, I have 0 minus 1, which is negative 1. So negative 1 squared is, right. So for this function, I had the point 0, 0. But for this function, when x is 0, y is 1. So that will be the y-intercept. How do I determine the x-intercept? Careful. For the x-intercept, I don't make x equal 0. I make y equal 0. Very good. So this is y, right? So x minus 1 squared equals 0. So where is the x-intercept now? Which x will make this 0? There is only one x that will make this 0. Negative 1 minus 1 will be negative 2. Negative 2 squared will be 4. Exactly. So where does this function go? Does it go to the right or it goes to the left? Exactly. So the new graph will be this. And here's your y-intercept of 0, 1. And here's the x-intercept of 1, 0. So what we remember now that when I change x into x minus 1, the graph shifts to the right 1. What if I change x into x minus 4? The graph will shift 4 to the right. Perfect. Excellent. Now let's say I want another function f2, which is x plus 3 everything squared. In the same way, where do you think this will shift? I'm still changing x. It's the same type of function, right? Same function, something squared. But this is x minus 0, but this is x plus 3. Where will this function go? Yes, because it will be 0 when x is negative 3. That's the reason why it moves 3 to the left. So this function is x plus 3 squared. Perfect. Next step. I want now another function. I want x squared plus 4. And I'm coming back to the original function, the base. It's called base function, the simplest possible function, a quadratic function. Now look at the difference here. This is x squared. There is no change in x. This is x squared, and this is x squared. But what is the change now? This is x squared, and this is x squared to which I add 4. So this is x squared. Where does the graph go? Depending on what I'm changing. If I'm changing x, the graph does this. If I'm changing y, the graph does this. What am I changing now? Since I'm not changing x, obviously I'm changing y. So where does this go? So if I graph again the simplest possible x squared or quadratic function, where will I be graphing x squared plus 4? If it's minus 4, it will be careful with that because I know it's kind of confusing. So it will definitely go up. So this will be x squared plus 4. Perfect. Now finally I want a function, let's say f4, that is x squared minus 3. All this discussion is for this. In a minute I'll come back to it. Exactly. It will be this. So this will be x squared minus 3. Perfect. Now I want to make a combination with these two transformations, they are called. So I'm going to say f5 is x minus 2 squared minus 4. There are two transformations, right? First, I graph x squared. Where am I going with x? It has to be in the order of operations. So first I graph x squared, and then where do I go with x minus 2 squared? Exactly, to your right. And then what do I do next? Okay, can you just imagine and tell me the vertex? Let's start from the beginning. One more time. So this is x squared. You told me to move 2 to your right, and then you said move down 4. So the vertex will be so now I want to come back here and I want you to tell me what is the vertex. And that's what it represents.
Which one? I'm sorry.
Exactly. That's it. That's the only difference from the previous shape, from the previous form. That's the whole thing. But I just didn't want to tell you, okay, the vertex is h comma k without discussing all this because I don't want you just to memorize h comma k. Okay, another example, and then we'll go to a graph in a minute. So I would like you to identify the vertex of this function. Nothing counts other than this number and this number when we talk about the vertex. This and this have no meaning when it comes to the vertex. Careful.
Oh, negative 1.
Exactly. Because it has to go to the left. So it's -1. This is straightforward, -1, 3. But if it's x plus 1, the graph goes to your left. Very good. That was the last thing I needed to present. So let's go and pick some problems like this one and graph them.
Oh, I was not.
Yes.
It's not about the work. Do we have class on Thursday?
So what I was, the reason why I wanted to meet with you is to review, and you will tell me if you want to have a class on Thursday, and I'll have to find someone because I'm going to a conference.
Okay,
So if you want me to find someone to review with you, again, what I'm going to do today, because I'm going to review everything today. So if you want to, then I will ask someone to be here for you. It's up to you. You can tell me at the end of the class. You can tell me at the end of the class. Every October, November, there is a conference. It's called AMATIC. American Mathematical Association of 2-year colleges. And this is the 43rd annual conference. And I've been to the last 8. So I normally go Friday and Saturday, but this time I decided to go on Thursday as well. Because there were very interesting presentations by our vendors from which we've sign books with and buy books from, and I don't want any books anymore. I'm gonna use open sources. I think the books are too expensive. Yeah. So, but I need to be there and see what they have to offer and what kind of websites, and I do have enough, but if we adopt any book or go with any vendor, then I like to know what they have to say. What I need to see their presentations before I have an opinion. So at the end of the class, I'm going to ask you again if you think that we need, that's why I wanted to give you the class back also for Thanksgiving, which we're going to miss, and also for Thursday. But if you think that we should be here, I will find someone to be here on Thursday and review with you. Okay, so let's go back. Where was I? Okay, all these problems are on page 696. 696. So let's start with, let's say, 18. 696. So we're given h of x equals x plus 4, everything squared minus 6. So the problem is asking us to graph, and of course I will put that list of 6 items that you have to present. But now, by now, we should have this graph in our memory, right? So I know that this is x squared. Where does the graph go first?
Left
4. And then,
down
what is the vertex?
-4,
Comma.
6.
Okay. Can you already picture the graph and tell me the range without even graphing it?
The range will be -1 to -1.
Careful. I'm here.
No, that's the
I'm going this way. Yes, the domain, you're right.
-6. So
That's it. So I already know a lot about this function now. So indeed the vertex, as you gave it to me, -4, -6. And you already know the range, -6 to infinity. So I already have the picture in my head. I still have to show those 6 steps, but I already know the graph and I will not make a mistake, right? Okay, so first is the shape. So remember, A is written in here, it's hidden because there is no other number than 1. So A equals 1, obviously it has a minimum, right? So it looks like this, as we know. So number 2, the vertex, you already gave it to me as -4, -6. Number 3, X-Intercepts. But first I want to think and see if they exist. I don't want to waste my time. So one more time, we started with x squared, we moved it to your left 4 and down 6. Does the graph cross the x-axis? Should I look for x-intercepts or not? Yes, because the minimum is negative. If the minimum would have been a positive number, then the graph would have not touched the x-axis. Good, very good. So now this part is slightly more difficult in this form. So in order to find the x-intercepts, what do I set equal to 0? Exactly. So then I have x plus 4 squared minus 6 equals 0. You could square that and then incorporate -6 and then use the quadratic formula. But we do have a very handy method that is perfect for this situation. What is that method? We know 4 methods. It's definitely not the quadratic formula. It's definitely not factoring. And the square is already completed. So which method will I apply? It's the fourth one, which was, if you remember, I said complete the square will not solve the quadratic equation. But the next method will, the one that has to be applied after we complete the square, which was? Exactly. So it's already set up with one minor change. I have to have 6 on the other side. So now I take the square root. I remember that I have to have, at the end of the day, how many solutions? 2. So then the left-hand side is x plus 4. It should have been the absolute value. Instead of writing the absolute value, what do I need to do? Exactly. You can't forget that. Plus or minus. And then x equals -4 plus or minus the square root of 6. Be careful where you put the 4. You cannot put it between plus or minus and the square root of 6. Plus or minus and the square root of 6 are connected. You cannot break that connection. So this has to be in front. And now I have to separate them and I have to approximate them. Because if you say plot this for me, I'll say, I don't know where. So with a graphing calculator, let's plug it in. So I will plug in -4 plus the square root of 6 and enter. And I also need, and here's how I recall the entry. Second and entry. And I just go back and replace +6, overwrite +6 by negative. So I have two solutions, -1.6 and -6.4. So now what are the x-intercepts as ordered pairs? What will you write? As ordered pairs, the x-intercepts are? Exactly. Because y is 0 for any x-intercept. -1.6, 0, -6.4, 0. Perfect. Now the x-intercept. I'm sorry, the y-intercept. How do I get the y-intercept? Always, for any function. I set x equal to 0, and now I have to be careful. So I have to find f of 0. Let's do this together. 0 plus 4. 4 squared. 16 minus 6. That's it. What is the ordered pair?
0, 10.
Very good. The last two are just words. Number 5 is the axis of symmetry. What is the axis of symmetry of this parabola? Axis of symmetry. X equals -4. Vertical line. Perfect. And one more time, the function has a minimum or a maximum. I know it's a silly question. We already have the picture in our head. Minimum. So I will have to write the minimum value of f of x is, we already have the range, so we know the minimum. -6. The last two always come from the vertex. The axis of symmetry is the x-coordinate of the vertex, and the minimum or the maximum, depending on what the function has, is -6, or the y-coordinate of the vertex. So now we're ready to graph, although we know the graph. We didn't even graph it, and we had the range, so of course we know the graph. So I have to start with the vertex, which is -4, -6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I plot this point. My next step is the axis of symmetry. It's not part of the graph. I have to graph it, though, to make sure I keep the graph in shape, symmetric with respect to this line, but it's not part of the graph. Then I have negative 1.6. I'm going to say this is somewhere here. And it has to be, the other point has to be perfectly symmetric with this one with respect to the axis of symmetry. So this is negative 4, negative 5, negative 6, negative 7, so somewhere here. So this distance between this x-intercept and the axis of symmetry has to be equal to this distance between this x-intercept and the axis of symmetry. And the last one, 0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to try to graph it as symmetric as possible. I'm not going to look with a magnifying glass. But try to keep it in shape. Is my graph perfect? Far from it. Always write the name of the function nearby, as we did with inequalities and systems. So this is f of x equals x plus 4 squared minus 6, so we know what we graphed. Any questions? I'd like to make one up, just one more, and then we can start reviewing. So let's say f of x equals negative 2 x plus 1 squared plus 8. Since we already had one with a plus, I'm going to say it's minus. It doesn't matter, really. You want plus or minus here. Okay. Now, immediately you can identify the vertex with no calculations whatsoever. Right. Good. So in part A, or part 1, I want the shape. Now I have to be careful because this is A. So then A equals negative 2, so the shape is not a minimum but a maximum. Perfect. Okay, I have the vertex. That's number 2, negative 1, 8. Since it has a maximum, can anyone give us already the range of this function? Right, but we write it from negative infinity to 8. Perfect. Number 3. See, now once you understand the graph, you'll be able to picture this in your mind, right? Number 3, x-intercepts. I don't want to waste my time. I want to analyze whether they exist or not. So the function has a maximum. Its maximum value is 8. Does it cross the x-axis or it does not? Yes, of course. So the x-intercepts are obtained when y is 0. So negative 2 x plus 1 squared plus 8 equals 0. Again, the same thing here. The best of those 4 methods is 4 methods of solving quadratic equations. The best one is take the square root. Very good. Of course, I need some steps in between before I get to taking square roots, but negative 2 x plus 1 squared equals negative 8. The next step must be absolutely. And then I get x plus 1 squared equals, very good. Now it's ready for taking square roots. So I take the square root, and I have x plus 1 equals. If I forget the plus or minus, I mess up the problem because I have to have 2 x-intercepts. Plus or minus 2, of course, thank you. So then remember 1 has to be right after the equal symbol. And it, of course, negative 1. So then I have 2 options for x. One with negative 1 plus 2 and the other one with negative 1 minus 2. So -1 plus 2 will be, and -1 minus 2 will be -3. So we found two x-intercepts. It is wise to write them as x-intercepts before you move on. So they are very good. Very good. Now 4 must be the y-intercept, which means I have to find f of 0. Yes? So let's go back together here. How much is 0 plus 1? How much is 1 squared? 1. How much is -2 times 1? -2 plus 8. This is the order of operations. I start from the inside, I square, then I multiply, and then I add 8. So it's positive 6. So the y-intercept will be 0, 6. Now two words here, just words 5 and 6. Axis of symmetry. Very good. And the maximum, since it has a maximum value is 8. That's it. So let's graph it. I have -1, 8. One, 2, 3, 4, 5, 6, 7, 8. Right here. Then the axis of symmetry, x equals -1. Then we found the x and y intercepts, 1, 0, -3, 0, and 0, 6. And here's the graph of this problem. I have to write the name next to it, and the name is -2 x plus 1 squared plus 8.
How do you find the axis of symmetry again?
The vertical line passing through the vertex. If the vertex is -1, 8, the vertical line that passes through it is x equals -1. Correct? Is that okay? Good. So you want to start with reviewing chapter 11 first and then going back to chapter 6?
Yeah, that's
Okay.